What's up, everybody? We're going to do 10.5 today, which is arc length and area of sectors. So let's talk about arc length. Shoot. I have a cool circle, and I'm going to say this is A, this is O, and this is B. So arc length is referring to kind of like the measure or part of the circumference of this arc right here, A to B. So in order to find that, because it's like kind of like circumference, it's a fraction out of circumference. So we're going to say the arc length of arc AB. So since we're talking about distance or part, we're actually going to be using the whole area, the whole circumference formula, 2 pi r. And we're going to set this as a ratio equals the measure of arc AB as a degree over 360 degrees. And we are going to be able to cancel things out. We are going to be using pi a lot here. Leave it in terms of pi. We want exact answers only. If you choose to put 3.14, I will mark you wrong. I will give you 0 credit. This is your warning. If you use 3.14, clearly you are not following directions and not watching the video and maybe just copying things down. That is not going to help you in the long run. Think about that. Please, please, please follow directions. Okay, so this is arc length. So let's talk about sector area now. So I'm going to be kind of using the same circle, except this time, instead of this arc, I'm actually going to be using this whole little pizza slice. So it's like a little piece of the area out of the entire area. So for this, the equation we're going to be using is area of the sector over, because we're talking about area, we're going to be using the area of the whole circle. So kind of a piece out of the whole equals the same thing. The measure of arc AB as a degree over the entire thing, 360 degrees, because the circle is 360 degrees. Part out of a whole equals part out of a whole. And this is area of the sector. Alright. Let's try number 1. And we're finding arc length. Arc length, we have a cool circle, A, B, this is 60 degrees here, this is 15. If this is 60 degrees, that means this has got to be 60 degrees. Just because the measure of the arc is 60 degrees does not mean it's the actual arc length. Because what if we're talking about centimeters? Because degrees are not centimeters. So let's kind of figure this out. We're going to set this up by, I'm just going to move this over here. We're going to set this up by saying, hey, we're going to have, we don't actually know this arc length, so we're going to call that x over 2 pi r, the whole circumference, so 15, equals, well, 60 degrees out of 360 degrees. The degrees cancel out automatically, which is pretty nice. We have two fractions equal each other, so we're going to cross multiply. X times 360, 360x equals 2 times 15 is 30 times 60 is 1800. 1800 pi. Well, to get x by itself, we're going to divide both sides by 360. And we are going to simplify. If you don't remember how to simplify, you can always do 1800 divided by 360. And if you get a decimal, you can always do math, enter, enter. But in this case, 1800 divided by 360 is 5. So our answer is 5 pi. Again, terms of pi only. Alright. Number 2 is still arc length. Got a good circle. This is 150 degrees, so it's a central angle. So this has got to be 150 degrees in a radius of 7. So when I set this up, I'm going to say I don't know the actual arc length of this. Let's say that's A and this is B. So I'm going to say x over the entire circumference 2 pi times 7 equals 150 degrees over 360 degrees. Then I can cross multiply. X times 360, 360x, 2 times 7 is 14, times 150 is 2100. So 2100 pi. Divide both sides by 360. And if you do 2100 divided by 360, you get a decimal. You do math, enter in your calculator. Because we don't like decimals. Fractions are our friends. We get 35 over 6 pi. So that's it for number 2. Alright. Number 3 kind of looks, we're finding perimeter now. Perimeter. And it kind of looks like the key on a basketball hoop. And I am going to say this is 12, this is 12, and this is 12 because they're all congruent. That means this has got to be 12 as well here, which means this has got to be 6. So the radius is 6. Well, that's cool. Okay, well, I need to find this. This is a half circle, which is a semicircle, which is 180 degrees. So if I do x over 2 pi times 6 equals 180 degrees over 360 degrees, automatically the degrees cancel out. I cross multiply. 360x equals 2 times 6 is 12 times 180 is 2160 pi. I can divide both sides by 360. X comes out to be 6 pi. So this up here is now 6 pi. But wait, we're not done because the directions say we gotta find the whole perimeter of this thing. Well, the perimeter is 12 plus 12 plus 12 plus 6 pi. Now, 12 and 6 pi are not the same. They're not like terms. Like you wouldn't add 12 and 6x because they're not exactly the same. Combine like terms. So the perimeter is 36 plus 6 pi. And we're good. That was it for number 3. Let's do a couple examples of area. Number 4. This is 12. 120 degrees. So when I'm going to set this up, I'm going to say, well, I don't know the area of this little sector, so I'm going to call that x over, well, I'm dealing with area, so the whole area of the whole circle is pi r squared, sorry. So pi and then 12 squared equals 120 over 360. And just like last time, I can cross multiply. So I get 360x equals 12 squared is 144. You know what? Let me actually just write this out. We get x minus 144 pi is 120 over 360. If I cross multiply, 360x equals 144 times 120 is approximately 17,280 pi. Divide both sides by 360, and that comes out to 48 pi. Again, if I told you units, you would say like 48 pi, I don't know, inches squared. Okay. Number 5. We're going to find the shaded area. So I got a circle, and I got a littler circle, and this part is shaded, kind of like a donut. Donuts are always great. So, the radius, I'm going to write small radius is equal to 2. From right here to here is 2. And then from here to here is 3. So if I'm saying this whole thing combined, the radius would be 5. Because 2 plus 3 is 5. I think I messed up on that with the notes. So we're going to find out who watches the videos today. Alright, so to find the bit, I'm going to find the big area. Let's see. I have area equals pi and then 5 squared. So the area of that is 25 pi. And for the small circle, small area, we can do area equals pi times 2 squared. Area of that is 4 pi. So to figure out the whole shaded area, I'm just going to subtract these two. 25 pi minus 4 pi is equal to 21 pi. Boom. We done with that. Okay. Not too bad. Number 6, we're also finding the shaded area. Got a box. Got a circle. My drawing skills are not the best, but bear with me. That's 10. That means the radius has got to be 5. And I'm telling you that this is going to be a square. So we know how to find the area of a square. Area is just base times height. 10 times 10. The area is 100. Oh, you know what? I should probably shade, huh? Color, 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 color. I like the color, yeah. I should go on American Idol or something. I don't know. Pretty good. Alright, circle. I don't want to do blue. I already did that color. Let's do red. Circle. Find the area of a circle. We know it's pi r squared. So pi 5 squared. Area is 25 pi. Awesome. So to find the shaded area, area is the whole square, 100, minus the circle, 25 pi. this does not come out to be 75 pi. We cannot combine these. That's it. We good. So that was it for 10.5. Man, we're almost done. We're flying through this. Please let me know if you have questions. I'd be more than happy to help you out, hop on Zoom with you. Missing you guys. Hope you guys are doing well. Alright, bye.